All right, guys. So here is the pentastar update. So what I did do is I did some calculations on port size, just to figure out where the restrictions on these ports are, the upper plenum, and then also to get a good idea of how big I want to make these ports. Um, Basically, and from what I looked at, and from what I've been checking out and kind of researching, and doing on these, is actually um well, maybe not be well known, but the stock Pentastar head flows 300 CFM on a flow bench, 28 inches of water. For those of you who don't know, basically, for every square inch of area, at a pressure of 28 inches of water, which is 1 psi, that area should flow 100, or its limitation is 146 CFM. So the smallest of one of these openings throughout the entire intake. I believe, let me see. Yeah, the smallest area wise is 2.26 inches. For 146 or for 310 CFM, the area size that you're going to need to supply those heads is about 2.05 inches. So indeed, all of these ports are larger or large enough to go and supply your heads. In fact, quite a few of them are larger. So the one that had the largest of the small cross sections, the largest of the small cross section, let's see, is 2.319 inches squared. So that is still quite larger than what is needed for the engine. Now, the engine obviously it's keeping its air fuel ratio by doing what it does. So the computer basically has two O2 sensors on each side, and they see how well the fuel is burning up, and they decide how much injector needs to be used. And the computer obviously, or the way the Pentastar computers are set up, is they auto learn to it in a certain limit to adjust to your air fuel ratio mixture by using speed density as their how much air the engine's taking in, and then obviously the O2 sensors to see how well the injectors are getting fuel to the engine. So what I am going to be doing here is I'm going to be opening these up all to a larger size, because your torque range isn't dependent on how small or big the cross section of the port is. So how big this is, your torque range is dependent. It's dependent on your velocity and ease of flow into the ports. And actually, it's quite a straight shot into the ports. But what that means is we can open up. If you can, this one shows it the best. You see all these lines? We can open up the ports to these lines because that rubber gasket that's going to be in here is actually sitting between here and like right here. So we can open it up to the line area on these, and that should give us a larger cross-section area, meaning more air can easily flow into the cylinders. And then based on basically what its reflection waves, it'll pulse back up and pulse back down. That will basically what it does is it kind of mini supercharges your engine and gives you your engine's RPM range. It's all a bunch of science stuff. Anyway, so what I'm going to be doing is I'm going to be opening up these to the cross section of this opening. And the largest of these openings is 2.3 inches squared. When we open it up to these lines, the cross section will be 2.8 inches squared. Or just about. It's not quite because you're not calculating in the corners. But it will be significantly larger. So So that's what I plan on doing. So it's gonna be like 2.85, 2.8 inches squared cross section area at this area of the port. Now, like I said earlier, there is other areas on this manifold that has cross section issues. Generally, so these here, these are the ones I labeled 4, 5, and 6. So 4, 5, and 6. These pinch points are actually the restrictions on these. Now the pinch points aren't that restrictive. They actually are larger than the stock size area of these. So basically everything on this port already is turning into a funnel. And that's kind of what I want it to continue to be when I open up these bottom areas. So these are the most restrictive, 4, 5, and 6, but it's still larger than the opening here. So that's not too bad of an issue. Now, 1, 2, and 3. So they have quite large cross-section areas. In fact, they don't really need to be open up. What I am going to be doing, because this one's the largest one, cross-section wise, I'm just going to be radiusing even a little bit more and more streamlined into the port as best I can. I may need to plastic weld, so just melt some plastic and make it so that transitions can work better for those. But that's what I'm going to be doing with 1, 2, and 3. I'm not going to change the cross section on 1 too much. 2, the cross section on 2. Let me get to the upper. Hold on. I wrote this down. Cross section on 2. So 2 is this one right here. So that on the upper plenum, the smallest area I could find on 2 is 3.31 inches. Actually, 2 is the largest. Never mind. So 2 is the largest, but the radiusing needs to be done to help open that up. So 1 and 2 are basically equal. They're about 100 thousandths in 100 square thousandths of an inch in difference. So they're close, and that's what I'm going to try to get everything else to, is that size, or as large as I can, basically. 3 is a little bit different. So 3 has 2.8430. You can see 3 is much, much smaller cross section of 3 than 1 and 2. Or 1, 2, and then 3. So 3 is going to need a little bit more work to open this up. Again, what I'm going to do is I'm going to plastic weld, so melt some plastic, some of the high temp plastic though, from the other. I have another lower intake I'm going to melt it from because it's the same exact stuff, and I will have a fan. Don't worry, I'm going to have a fan taking all the fumes away. And then obviously some gloves, plastic welding with a solder gun, right? All that big deal. So what I'm going to end up having to do on a lot of these, I'm going to have to plastic weld in the bottoms here to do that. Now, 4, 5, and 6, again, I said they are restricted. So I was trying to see if I had any wall thickness to take off. And unfortunately, I really don't. So basically, what I decided to do, because I want to at least get these runners up to the 2.85 inches that are going to be at the bottom, because right now they're larger, but if I increase the bottom, they'll be smaller. So what I most likely am going to be doing, I'm going to be plastic welding, adding plastic material on the tops for those, and the bottoms. The tops and the bottoms to increase that cross section size. So then so I can open up the tops and the bottom to get that cross section size I need to get the air through that. I need to equal that 2.85 just to keep the air linearly and flowing. Now, another thing is some of the other ones, the one, let's see, 2 and 3. So 2 and 3 do have, or they will have, a cross-section limitation when we get to they will have a cross-section limitation once we start actually porting the bottoms. So with the bottoms, basically what we're going to have to do, and I noticed this too, I didn't do it to all of them, but there's a cross-section right here. You see where that line is? This side of the wall needs to go back and straighten out. Now, I know I don't have too much material here, but I should have enough to get this width back and forth to be equal to the opening once I open it up. So basically, it's just going to be deep port match way up into there. And then get the right cross-section size on the top ends. And basically, I'm going to get them all to be about the same cross-section size, up about another half square inch of cross-section on these heads. So we'll have another half square inch of cross-section on these heads. And there shouldn't be any more restrictions then. Really, then what's controlling your air-fuel ratio then? For sure, like, it'll be a lot more responsive. But what will be controlling the air-fuel ratio is, again, that opening inlet. And again, because the engine will more easily be able to see more air, you'll be more throttle responsive. And keeping that 76 millimeter throttle body, like I said again, that's worth slightly over 1,000 CFM at 28 inches of water. Now, an engine, so they calculated this back and over, but an engine at the size and displacement of the 3.6 pentastar, even at 7,000 RPM, won't need more than 650 to 700 CFM, or equivalent of 650 to 700 CFM of port area, and then also of intake carb. So the 76 millimeter throttle body will be more than enough. Now, another issue I kind of been thinking about and ran into. I was thinking of getting like a PCV pipe. I know this isn't PCV, but anyways, what I would do, cut off the throttle body section here, right? So cut this off. I don't even know how big this is. I don't think it's 3 inches. I think it's smaller. So cut this off, get some PCV pipe, attach it to that, make it straight, cut off like half the PCV pipe, weld it to this, plastic weld it to this, and then have that run into the runners. So that was my idea on that. And then obviously this will be on a charger. It'll be a little bit different because it basically part of the issue that we would have is we have the EGR system on the oil catch can system. So that might be an issue, although I might be able to just set up an oil catch can to figure that out. And then your power brakes, your vacuum. But what I might do is I might just take like this whole little section thingy here, where the vacuum runs right into here. So you just cut something off like that. Then you plastic weld and high temp silicone over that. So that's what I might do with that. But this is going to be one of my summer projects. And hopefully you guys like this video, and you'll see more updates in the next one.